Hello, everybody. My name's Tim Lankish. I am the Director of Engineering at CAE Services Corporation. This is our Ask the Moldflow Experts webinar. The topic for today is how to identify and solve warpage problems. So let's get the first one, maybe one of the most important ones, out of the way. How accurate really is it? This is something we worked on 10 years ago. Here's a critical dimension that needed to be met. The predictive analysis on this showed that we were about 1.7% off, so pretty darn accurate. And this is really why I love Moldflow so much, because it allows us to separate out the different causes of warpage and how much each cause is contributing to the overall warpage. You know, we're talking less than 1/10 of a millimeter for the cooling and orientation effects, so very small contribution. But look in the upper right, the shrinkage component of that, we're seeing negative 1.4 millimeters. You look at that, you compare it to the total warpage in the lower right there, and you see a pretty good match. So this tells me immediately that this is a shrinkage issue. Packing pressure and time. This is a big one. And this is a two-shot overmold. I got some questions beforehand about whether or not we can predict warpage with two-shot overmold, and the short answer to that is yes. And in this case, you know, I see this a lot with processing standards at different companies. You know, you have your book of standards, right? And a lot of processing teams say we will pack at this amount of time for this material, no matter what. And that's a bad way to go. This is one of those cases where I don't remember the exact time off the top of my head, but it was a very short packing time, something like 5 seconds. And when you do that, you're affecting the shrinkage of the part in question. So in this case, you see a very large amount of warpage in the part when you pack a short time. And then when you pack a much longer time, you see how much the warpage changed. I mean, we're talking 41 millimeters here versus 5.8.